All right, here we are continuing on with algebra notes for 8-4. We're going to take a look at example number 1 here. So we are given a sub 1 is equal to 8 and a sub n equals a sub n minus 1 minus 5. So remember that a sub n minus 1 is just talking about the previous term, right? The term that came before a sub n. So find the next 3 terms. Well, if I'm starting with a sub 1, obviously I can't find a sub 1 because they already gave it to me. So that means the next logical thing I'd be looking for is a sub 2. Which means if I'm looking for a sub 2, that means that my n is equal to 2 here. So in that equation that they gave me, or that formula, everywhere I see an n, I'm placing 2. So a sub 2 minus 1, taking extra care to make sure that that minus 1 is part of the sub and not just looking like a sub 2 minus 1 minus 5. Very big difference in what those two things say there. Your handwriting is going to be key. So then the only little bit of math I can do is a sub 2 minus 1 turns into a sub 1 minus 5. So I can't figure out what this is unless I know what a sub 1 is. This is telling me that to get a sub 2, I need to take a sub 1 and minus 5 from that. Well, luckily, they gave me that a sub 1 is equal to 8. So I can now replace a sub 1 with 8. Giving me an a sub 2 value of 8 minus 5 is 3. So I wanted to really make that fit, but a sub 2 would be 3. Moving on to the next one. I already found a sub 2, so now I want to find a sub 3. A sub 3 is equal to, again, everywhere I see an n, this time I'm using n equals 3. Everywhere I see an n, I'm putting that 3. A sub 3 is equal to a sub 2 minus 5. In order to do this, I need to know that a sub 2 is that 3 that I found it to be. 3 take away 5 gives me with an a sub 3 that is equal to negative 2. Next 3 terms mean I need to go up to 4. So for this next one, a sub 4, I'm using an n value of 4 this time, is equal to a sub 4 minus 1 minus 5. A sub 3. So I now know that a sub 3 is that negative 2. Negative 2 minus 5 more leaves me with an a sub 4 of negative 7. Really important that you're organizing that so I can tell what you're looking at. All right, so maybe you can notice the pattern here, or what I'm doing to get from 3 to negative 2 to negative 7, or what I keep doing to that previous term. That's what it's asking you to do here by explain it in words. What we're doing in words is subtracting 5. You're subtracting 5 from what? From the previous term. That's what recursive means. Recursive, when you see that recursive, you always want to be talking about the previous term. All right, is this arithmetic or geometric? Does it have a common difference or a common ratio? Well, I'm not multiplying by anything, so no common ratio, which means that it has to be arithmetic. And it's arithmetic because there is a common difference of minus 5. And create an explicit equation to represent this, or to replace that recursive. Remember, explicit just means a regular, normal equation. Well, because we said that this was arithmetic, that means this is a linear, right? Arithmetic has that common difference, aka that slope or your constant rate of change. And so if it's a linear, that means it has the y equals mx plus b format. I already found my slope to be that -5. I would just need my y-intercept. But again, remember that y-intercept is not a sub 1. Remember, I don't know where I want to write this. Let's write it at the top. Remember that a sub 0 is your y-intercept, not a sub 1. So we are going to need to do a little backwards work here to find out our a sub 0. Well, if a sub 1 was 8, and I knew that I was minusing 5 to get to the next term, if I want to go backwards from minusing 5, that would be adding 5 to get to a sub 0. Let's go red. So a sub 0 is going to be equal to 8 plus 5, giving me an a sub 0 of 13. A sub 0 equals 13. So a of n, or a sub n, is equal to -5n plus 13. Or a sub n, if you want to use sequence notation. And there we have it, example numero uno.